Hi, good evening, and welcome to my daily live session on various topics for execution excellence. My name is Dinakar. I'm the founder of Samuthana and the inventor of doHow, a methodology for driving teams to achieve challenging goals and realize amazing outcomes in a situation that is stable, in a situation that is quite matured, by changing their mindset and culture. That's all what we do as far as the leadership is concerned. And on the other hand, by acquiring new skills to make sure that the management systems improve through continual improvement using our learning cycles. So I've been talking about these learning cycles for quite some time now, almost 4 or 5 weeks, and this week it has been about the productivity cycle. And I will talk today about the opportunities for automation. How do we identify that and what can be done there? And before I go there, let me invite you to visit my website or our website, dinakarmurthy.com it is, or write an email to me, dinakar@samutana.com is my email ID. And also I would like to invite for our weekly doHow session, a public doHow session on Sunday at 11 o'clock. You can use the link indicated in this video and also in the description to join in on Sunday at 11 o'clock and experience doHow for yourself. With that very brief introduction, let me directly jump into the topic of the day, which is about the continual learning. And I started by introducing what is called as a control loop. This is something which is very, very important. The first area of any continual learning is to have the understanding of a control loop, which have four phases actually. When it comes to technology, which is what smart manufacturing is all about, I would use these words as algorithm, actuate, sense, and correct. Otherwise, it would be the plan, do, check, and act. The first topic would be to have an algorithm ready. Algorithm is something which defines the cause and effect and what needs to be done at a particular situation, in a particular situation. So based on the algorithm, an actuation is done. That is the do phase of the PDCA cycle. And once the actuation is done, in the environment, something changes. And that change is sensed using modern sensors, all possible sensors available today, temperature, humidity, pressure, even movement, distance, multiple sensors are there. You sense the change in the environment, and based on that, the difference is found out between the intended outcome, which is what that came out of the algorithm, and the actual outcome which came out from the sensor. And this then gets corrected. That is the act phase of the control loop. And this is something which is common for anything. It's not specific for manufacturing or specific for any other industry. Now, this control loop is something which is the essence before we really go to the next step, because many a times we do a lot of things only to check, a lot of things only to actuate. Unless there is this entire closed looping, nothing much will happen. So that's the core essence of what I'm trying to say in terms of the continual learning. So all the four cycles, all the four phases of the cycle are equally important: the plan, do, check, act, or algorithm, actuate, sense, and correct. Now, using this foundation, I then went on to define the various learning cycles in any organization, starting from the product cycle, which is basically to make sure that the product is developed and it is viable, and after that to make sure that this product can be produced using a process. Then the people, because the people then need to be trained and need to be brought up to speed to really use those processes to produce the product. Then comes the performance cycle. Now, once the people are trained and they're in place, then how do you make sure that people are delegated, people are given tasks, and people are given goals so that they can perform as intellectual human beings? And then once they are starting to perform, the performance is stable. We come to the productivity cycle, where we are looking at opportunities for improvement, mainly improvement in automation in this context, because we are trying to see how technology can be enabled to make our lives much easier. And then comes the next one, which is the programming cycle. Of course, productivity cycle also means that improvements could be done in terms of the way the job is done, the content, the list of activities, all that can be improved. But the most important thing is to find out where we can automate it, and that's where technology will help us a lot. Where we go on to the next cycle, with the programming cycle. And once the programming cycle is done, that means we are able to program whatever that the control loop that I'm talking about is in place. Then we get into the progression cycle, which is the progression of the society. It could be, you can call it as the what could be smart communities, a smart living, where it's not smart buildings today. Smart living would be where you're trying to have a closed loop system for garbage collection, closed loop system for electricity distribution, closed loop system for water consumption. When I say closed loop, I'm talking about the closed loop control system. That means depending on how much water is consumed, I'm making sure that the water gets pumped into the reservoir. Everything gets closed looped, and depending on how much the T&D losses are, that is the transmission and distribution losses, the respective subdivisions in the electricity distribution network gets corrected, and we find out where the leakages are happening, and then maybe there will be automated intuitive messages to say that, look, you need to put a smart meter, or you need to really monitor the current that is used, or the energy that is used in a particular line, where you know that there could be a potential T&D loss, transmission and distribution loss. So those things would be the smartness, and that would be the last phase of progression. So before we go to the progression cycle, let me continue with the productivity cycle. So yesterday, day before yesterday, I spoke about setting challenging goals. And yesterday I spoke about continual improvement, what could be done in continual improvement. Unfortunately, in the productivity cycle, most of them is human intelligence, automated intelligence is not possible, machine intelligence is not possible. Now we look at where it can be automated, and this is where to some extent technology comes in place, and we could really use some kind of a automation activity here to accomplish these tasks. And therefore we need to first identify what can be automated. Only then can the automation be done. So today I'll be talking about what can be identified as automating possibilities, opportunities, and then to redefine how do we automate it. So first, and then to define the algorithm, because then you need to know the algorithm. Once the algorithm is known, then we can start writing a code, a program can be done. So first is the closed loop control for machine. This is something which is very, very a dream project of mine. I had seen this happen in Germany for many situations, and in fact we had within our organization too similar technologies developed. Wherein imagine a situation where there is a CNC machine. It could be a CNC machine which is machining, or it could be an additive machining, which could be a 3D printer or whatever it is. Now imagine that you measure the component after the machining is done. I'm talking about making multiple components, not just one component. If it is one component also, it's fine. Let us say if it is one component, I machine to some extent, and after that, I know what dimension I had given and measure it in between. And once I measure it, and then that measurement is taken as a value, the value that was measured is taken as a input, and the offset is calculated for the tool, because there could be some offset required for the tool, so that the targeted dimension can be reached, and that then gets input into the machine. Of course, there are very, very sophisticated systems where this measurement is done in process. The machine tool manufacturer himself supplies such machines, and grinding, it is very common. It's called as in-process grinding, or in-process match grinding, in-process size grinding, or the various two different technologies that I know. This has been in vogue for more than 30 years now. Using in-process measurement equipment, which could be kind of a transducer or a linear variable differential transformer, which would check the position of the particular component and the size of the component on the machine itself. And based on that, the feedback is given back to the control system to either increase the depth of cut or reduce the depth of cut. And that technology has been in vogue, like I said, for more than 30 or 40 years now. And my first activity in my professional life was to work on that particular machine to improve the process capability of that kind of a technology. And we were manufacturing a component in Bangalore with tolerance of 3 to 5 microns. 3 to 5 microns. Again, I repeat that. 3 to 5 microns is quite small tolerance wise. The hair diameter is about 120 to 150 microns. My hair may be about 190 microns because it's become quite thin. A normal hair would be about 120 microns diameter, and imagine slitting that hair into 100 slices, and one slice would be 1 micron. Like that, 3 to 4 microns would be the tolerance. Within the tolerance, you have to manufacture, those days, maybe about 20,000 parts a day. I said 20,000 parts a day. 20,000 components a day had to be manufactured to that tolerance. So we had match grinding machines, size grinding machines, in-process measurement. And there the idea was very simple, like I explained in the first slide. There is an algorithm, because this again is something which is important. I think those of you who are mechanical engineers can understand that whenever the the calculated depth of cut or the calculated size to be machined is 4, and you make sure that the machine advances by 4, then you would not get 4. You would get 3.8 or 4.2 depending on what you are grinding. Reason for that is what is called as a machine spring constant. Because of the various materials used in the machine, and many of them are elastic in nature, elastic in terms of microns. I'm not talking about millimeters. And they are elastic in nature. And second is there are clearances in between all the machine elements, and therefore it could either be positive or negative depending on what you are measuring. Now, this particular phenomenon is common across all the machines. All the machine tools have the same phenomenon. And therefore, it is important to measure the component during the process, after the process, and find out what is this spring constant. You could do it arithmetically or empirically. It's very simple. You give the input as 4, the output comes as 3.8, second input as 5, it comes to 4.7, third input as 6, it comes to 5.6, for example, and the difference between the two is what is calculated, and that is fed back to the algorithm. So it's an empirical way of calculating the target value rather than the theoretical way of doing it, and that's something which works, and it's been working for ages now. Now, same concept can be used for machining centers too. And again, here there are probes available from Rheinischer as a manufacturer of probes, where you can fix it on your vertical machining center, and it can be used for measuring when you are machining it. That is one option. The second option is you could that's quite an expensive one. Otherwise, most of the companies have CMMs. CMM is coordinate measuring machine, 3D coordinate measuring machines, and these coordinate measuring machines can measure all the dimensions on a component. Imagine if the coordinate measuring machine could measure all the dimensions on the component, and that report is then fed into another system which basically finds out what was the depth of cut or the position defined in the program, and what are the actual dimensions that we got, and the difference between two you calculate it for 3 or 4 components, and then after that try to find out how is this pattern working, and for that machine learning can be used, which is the modern word. And what I explained to you, the percentage is nothing other than machine learning, which existed for 30 years. Now today we call it as machine learning. So that particular difference can be checked out, and then the offset to the CNC machines can be given automatically. I am telling why is this required. Now look at it. In all the manufacturing sector, especially the smaller and the medium sized companies, the key player there is a setter, because many companies have got only 3 or 4 machines, 5 machines sometimes, or 6, 7, up to 10 machines also it could be there, 15 machines. Setter is a very key person because he's the only one who can give the offset. Otherwise the operator will basically load and unload the component. That is not that skilled. It's not a very highly skilled job. Therefore, if you have got the shortage of setters, which is a very, very highly priced commodity in the market, it's not easy to get a setter who is good, because the setter knows if the variation was 30 microns, I need to give an offset of 28 microns, or I have to give an offset of 32 microns. That comes by experience, and that again is empiry. There is no theory in that, and that kind of a calculation could be automated, and then the machine can get fed with the offsets automatically from the 3D measuring machines. That is something which is my dream project. That is number one. And the other one, where you talk about the measure, offset, and upload. Upload the offset, measure the dimension, calculate the offset, and upload it. The other one is, imagine in cutting tool industry, you got these are all opportunities to automate, because that automation really increases the productivity, because and the dependency comes down on very highly skilled people. And this can be done at a fraction of a cost. The initial investment definitely is there, and after that it will be recurring cost will be almost zero, because you're only using a program to do that. And remotely you can adjust in case the variations are not acceptable. You could adjust it remotely by changing the factors. That is something which is useful. The other one is imagine the machine loading and unloading. This is something which is quite common, quite well known, where you could use either pneumatics or hydraulics. In this case, you are basically automating the mechanical movement, which means physical strength is what is automated there. And for that, again, today it can be done using stepper motors and CNC controls, instead of going in with the hydraulic or pneumatic controls, or maybe PLC systems. That is not required. You can use using numerical control systems are possible. Then material movement and transport, again another area where automation can be done. Material transport is something which can be done using robots. Yesterday, in fact, I saw a video of what is called as bionic hive, and may I write it down here, you can also check it out. One of my colleagues had sent that link to me. It was quite an interesting video. Innovation in USA, bionic hive. This is the name of the company. I just added that. Now I'll remove this ticker, hide this. Yeah, this can be there, yeah. So Bionic Hive is the name of the company, bionichive.com, and they have a robo which can basically go on to the stack, go on like a stacker. You know, you let's say multiple vertical storage racks are there, and it can go along the vertical storage racks using a channel, and then pick up the item whatever that you want and bring it down, and then move around in the entire space without any problem, because it is all guided through possibly beacons, and GPS may not be possible inside a warehouse, but then beacons are there, and through beacons it can find its way out, and then it gets guided inside without really hitting any other robo. So multiple robots working in harmony, and that is something which can be automated, because that is one area where we lose a lot of time, and the quality also is not very good, because the picking and issuing of items is not always 100% accurate. There always are issues in terms of quantities, in terms of what item got issued, etc. Because it's all manually done, and that can be done using robots. That is the second. And the other advantage is manually many a times we misplace the items. In the case of a robot, it won't be misplaced. Wherever it goes, it tells the computer, so that particular location gets captured correctly. Then in terms of movement also, it can be automated from the stores to the point of usage, and that can be done using again robots. A long time back, this again I'm talking about 15-20 years back, all these technologies are in there. You know, it's not something new. Technology is always there. Only thing is, it was not that much bright, what should I say, spread out. And now with the common understanding of IoT and Industry 4.0, most of these technologies are getting more and more spread out. There is this possibility of having magnetic strips on your floor, epoxy floor, for example, and then run automatic transport vehicles, you know, with which have sensitivity for human movement. Whenever there is any object in the front, they'll brake on their own. Otherwise, they'll keep rotating. You know, you have milk runs in the factory, and this is a fantastic concept for milk runs in the factory. It's an automated railway system within the factory. So that's again another area where automation can be done. Then repetitive business processes. This is my dream project. I do quite a lot of that using low-code platforms where workflows can be automated. And if you look at it in companies today, there are a lot of systems in place, but then the bigger problem is people don't many a times use it. I was talking to one of our clients today where they have fantastic checklists and fantastic system, but guys don't use it, you know. And that is the place where we work. That's the mindset part of doHow, which is what I explained in the beginning in my introduction. And to learn that, you can come on Sunday, I said. So where you're basically creating some kind of a debate and a discussion to increase the awareness. And once the awareness improves, knowledge improves, people start using it. So with that, I come to the end of today's discussion, today's live session. Tomorrow, I'll be talking about a different topic, that is the act phase or the correction phase of the productivity cycle, which is to create a control algorithm. And once the control algorithm is created, again, you look at challenging goals and again do the same cycle, so that the control algorithms become more and more perfect to meet those challenging goals. That's the idea. So we talk about that tomorrow. And till then, for those of you in India, have a nice evening. For those of you outside India, have a great day ahead. And for both of you, all the very best, and see you tomorrow more or less at the same time. Goodbye.